Okay, just assume we have a 5-star hotel. We have a 5-star hotel where we have a large load divided, okay, a large load divided into small loads. Suppose we have 100 rooms, each room needs 2 TR. We have 100 rooms and each room is required with 2 TR. So what type of machine will you choose? Any guesses?
We have a large room which 2 TR R6, sir.
What type of machines will you choose?
Can you please repeat the question, please?
Yeah, I'll repeat. We have 100 rooms. Each room is with 2 TR capacity. Okay. It's a 5-star hotel. Now, that means nearly around 200 TR, right? Nearly around 200 TR. So as it is nearly around 200 TR. Okay, as it is nearly around 200 TR. Which type of machine will you choose?
Chiller unit type.
What? Chiller system. So suppose you are telling AHU, right? So very good. Nice. Okay, very good. Nice.
So VRV system also comes into picture, right?
But gas will be there na, in VRV, and electricity bill will be more.
Yeah, but I have seen cases they use VRV system for such huge plants.
So for your kind information, I'm telling you tomorrow I will not be available. Why? Because I have some project meetings. Okay. So you can plan anything tomorrow. Okay. So this is like this: room 1, room 2, room 3, room 4. We have 100 rooms. Think each room requires 2 TR. Each room requires 2 TR. Okay. Now, as each room requires 2 TR, as per the Sandeep. So we'll take one AHU and we'll connect to all the rooms by using the duct. Right? Okay. We connect AHU to chiller. Hope you got the point, right? Now, it's a season like non-holiday season. It's a non-holiday season. So, in a room, will all the rooms be filled?
No.
No.
Will all the rooms will be filled? No, right?
No.
So then
No.
if you connect one AHU with 100 rooms, will the energy is going to be wasted?
Yes.
Yes. So to eliminate that, we have come up with this with a system called as fan coil unit. Okay, fan coil unit. So fan coil unit is same like fan coil unit is same like HU only. Same, it works. The principle, the components are all like HU only. But the working process is quite different. That's it. So in the fan coil unit also we have cooling coil, filter and blower. Cooling coil, filter and blower. So fan coil units or terminal units, you can say. Fan coil units are available in a capacity from 1 TR to 3.5 TR. That means 400 CFM to 1400 CFM. Okay, 400 CFM to 1400 CFM. So one is supply, one is return. Here return duct is not required. Okay, return duct is not required. Why? Because we are placing this machine near to the return terminal only. In the same false ceiling it will be there. Okay, so that is the reason no required of return air duct. So we have chiller, from chilled water line, supply and return I am showing in a single line. Chilled water line is connected. Okay, chilled water line is connected. So if the same air, so from here we connect, we connect with a thermostat here. This is connected to a thermostat. So whenever we switch on, this machine runs. Okay, and you can supply them. So here same air, okay, same air is circulating, so you need to maintain fresh air, right? You need to supply fresh air. To supply fresh air, if this room is having a balcony, so balcony like this, so for the doors we have This is called as grill. Okay, this is called as grill. Sorry, grill. So technically this is lure. Lures are connected to exchange the air. Here no separate calculations are done. Why? Because just we are two people in the room, 2 to 3 people, right? That room is designed for 2 to 3 people. Just the fresh air which enters in is enough to maintain the fresh air. Suppose if this is not having a balcony and you don't have a space, or you don't have a possibility of placing, okay, you don't have a possibility of placing the lures, then you need to run a separate duct. Okay, you need to run a separate duct for the fresh air. From outside we run a separate duct for the fresh air. Okay, is everything fine? Now how we are going to save energy? How we are going to save energy by using, okay, how we are going to save energy by using the by using this fan coil units. So here let me tell you a small fundamental on this, basic fundamental I am telling, sir. This is chiller. This is FCU 1. This is FCU 2. This is chilled water supply and this is chilled water return. So for every FCU we have connected with a three-way valve which is connected to room thermostat. Bypass valve or three-way valve. Now let's assume we are supplying 5 degrees centigrade of chilled water to FCUs. Okay, 5 degrees centigrade chilled water we are supplying, and both FCUs are on now, so that you are getting 20 degrees centigrade of chilled water return. Okay, 20 degrees centigrade of chilled water return. Now let's assume a scenario. One FCU is working, one FCU is not working. That means we have switched off FCU 2 and FCU 1 is working. From FCU 1, as similar, you will get, sorry, before going to this, so now chiller has to decrease the temperature, delta T, change in temperature. So delta T, कितना है delta T? 20 minus 5, which is 15 degrees centigrade. That means the chiller has to decrease the temperature of 15 degrees centigrade. Okay, now the scenario starts. So now FCU 1 is working. Same. Yeah. Yes, any doubt?
No, please go ahead.
Okay. FCU 1 is working. This is same. 5 degrees centigrade will come and it will become 20 degrees centigrade. But FCU 2 is not working. FCU 2 is not working. That means we have switched off in that room, no one is there. So the bypass valve activates and it supplies water from the bypass line. So the water will become 5 degrees centigrade only. Now this 5 degrees centigrade comes and mixes with 20 degrees centigrade. So will the temperature of water decreases here? The temperature of water is going to decrease right here.
Yes, yes.
So the equilibrium temperature, if I talk, it may be around 12.5 degrees centigrade. 12.5 degrees centigrade. It may be around. Now the delta T, now 12.5 should become 5 degrees centigrade. Therefore, the delta T is 7.5 degrees centigrade. So now here, as delta T is decreased, so that the running cost of the project is going to decrease. So sometimes in a big scenarios, if you have 100 or 50 FCUs at that particular time, no need to run the chiller for half an hour to 15 minutes. Same water we can recycle. Okay, that cooling is enough. If I decrease 5 degrees centigrade and I recycle for half an hour. Why? Because all the FCUs are not working, right? Okay, that is the scenario how we are going to save energy by using fan coil units. Okay, this is only applicable when we have a large load is divided into small loads. Okay, that is the scenario where the large loads are divided into the multiple loads. Okay, now second point, where we are. Okay, so as I previously told, this system is called as, I'll talk about this fan coil unit. This system is called as all water system. In all air system, we are supplying air from outside. Completely, you are taking air from outside and you are supplying to the room to cool the room in the yesterday's session, right? Okay, and here you are not supplying any air here. Same room air को हमें recirculate कर रहे हैं. Okay, same air we are recirculating. So from outside, what you are supplying to cool the room, we are supplying the water from outside. So that is the reason it is called as all water system. So yesterday we are supplying completely air from outside. So it is called as all air system. Clear? Now, if we use in a single project, suppose assume a 5-star hotel. In the 5-star hotel, we have a banquet halls, reception areas, restaurant. These are the bigger applications where we need to use AHU. But if you come to the individual rooms, suites and rooms, we need to use FCUs. So it is a combination of multiple systems. उधर हमें all water system भी use करना पड़ेगा और all air system भी use करना पड़ेगा. ठीक है, all water system भी use करना पड़ेगा, all air system भी use करना पड़ेगा. So all water system and all air system should be connected to a same chiller. All air system and all water system should be connected to a same chiller. So that system is called as air water system. That system is called as air water system. Is it clear? When we use a project with all water system and all air system are connected to a single chiller, then the system is called as air water system. Hope you are clear, right?
Yeah. So in air system, all air system to the chiller we connect AHU. In water system we connect FCU.
Yes, that's it. Difference.
Yeah. The chiller is common.
Chiller is common. The water system is common.
Okay. How do we calculate the chiller capacity?
Will come. We have a class called selection of machines.
Okay.
So are you able to see the screen here?
Yes.
Okay. So this is a sample of AHU. AHU sample है. In this is filter. This is cooling and heating coils. Okay, cooling coil and heating coil. So कुछ projects में क्या होता है ना, cooling coil separate होता है, heating coil separate होता है. Okay, and this is blower. This is blower. You can see the blower here, and blower is connected to a motor. Okay, blower is connected to a motor. Just you are not going to design any of this machine. You just give us a capacity, how much capacity of machine is required. So according to that, our manufacturer will manufacture. Okay, I'll show one more image. So you are able to see this is how the AHU looks with outer panels. Okay, these are all access doors. This is supply duct, mouthpiece, and this is for return ducting. Okay. You can ask me, how did you tell me this is supply duct and this is return duct? You can see the arrow mark right here. Are you able to see arrow mark here? This arrow mark indicates how the air is flowing forward. Okay. Next. So this is how the FCU looks. Okay, FCU, how FCU is going to look. So we have a coil. This is the coil. Here you have a filter. You have a blower in between. Okay, and this is a drain pan. So when there is a dehumidification process, the water will come, right? Okay, dehumidified water that has to be drained. So this is how FCU looks. So FCU will not have any outer panels, sir. Why? Because you can see the blowers very clear here. Okay, so FCUs will not have any outer panels. Why? Because that is again FCUs are concealed. We place in the concealed spaces. Okay. So this is how the chiller looks. Are you able to see chiller here? Okay, this is how the chiller. One is condenser, one will be the condenser, one will be the evaporator, and we have a compressor, and somewhere you will get the expansion device. Okay, this is how. This is called water cooled chiller, sir. Water cooled chiller means if the condenser is cooled by water, if the condenser coil is cooled by water, then it is called as water cooled chiller. And you can see here this indicates the air cooled chiller. So here the condenser the condenser is cooled by air. Okay, evaporator is water cooled, but condenser is air cooled, so it is called as air cooled chiller. So if you come to the places like Dubai or Gulf countries where there is a where we can't find water for drinking purpose, right? The drinking water is so costly. So in that particular applications, where we are not able to find water, then we use air cooled chillers. So you can see image, this is air cooled chiller. Got it? Next. So are you able to see this image? What is this basically?
Chiller plant.
Yes, this is the chiller plant room. Okay, where we have multiple chillers. Why? Because if you come to the data centers, or if you come to the applications like Amazon, Hyderabad, you can come to the Hyderabad, Gurgaon if you go, or if you go to Chennai, the IT sectors, IT companies, where we have n number of floors. Each floor will have one AHU, and all these AHUs are connected to the chillers. Okay, we need to maintain a chiller plant room where it looks like this, all the chillers. Okay, and their piping, this is piping. So here we are going to design, we are going to calculate the capacity of chillers, we are going to find out what is the pipe required, size of the pipe. Okay, what are the fittings we need to use, what are the different types of fittings we need to use. Okay, all this comes in the further classes. Hope you are clear, right? Some idea you got how the air conditioning systems in the industries are going to work. How many of you
Yes.
got idea? Just raise your
Yes.
hand or thumbs up. You can give some reaction, right? Yes, good.
Yes.
Okay, now now so in the previous session we discussed on duct size, ducting. Now in the today's session we'll start working on duct sizing. Okay, we'll start working on duct design or duct sizing. So if you want to make a note of this, you can make a note. I'll give 2 minutes time, 2 to 3 minutes. Build water piping. Return terminal. Terminal. Got it? Fall ceiling. FB, flexible duct. Make a note. So by 8:10 we'll start the duct design. So from now everything should be noted, sir. Everything is a calculation base. Okay, make a paper, pen, book, everything.
Sir, what is FD?
Flexible duct.
Hello?
Flexible duct.
Oh, okay.
Yes, hope it is done right.
Yes.
Next, duct design. What is a duct basically? What is a duct?
Medium where the water, the air flows.
Yes, very good. Duct is a passage or a conduit, you can say, for the flow of air. For the flow of air. Duct is a passage for the flow of air. Simple definition we can go. So, coming to types of ducts. Supply air duct, return air duct, fetch air duct, exhaust air duct. These are the different types of ducts. According to our application, we use the types of ducts. Next, duct shapes. What are the different shapes of ducts we use in the industry? Round duct, so in the round duct, we'll find the diameter. Okay. Square duct, rectangular duct. So square and rectangular ducts we find width and height, where in the square duct we find okay width only, so that height will be the same. And I have one, dia two. Okay. Types of ducts. Sorry, types of duct sizing methods. Directly go with duct sizing methods. Velocity reduction method.
What is the name of that fourth duct?
Sorry, Wowell duct. Velocity reduction method. Equal friction method. Velocity reduction method and equal friction method. Okay, so to find any size, you need to have some parameters. You need to have some parameters. So to work on velocity reduction method, you need to have volume. We take in terms of CFM. CFM means cubic feet per minute. CFM is cubic feet per minute. And we take velocity. FPM, feet per minute. So, did you receive materials or handbooks? Did you guys receive handbooks?
Yes.
No, no, sir, not yet.
Here we have velocity. Here we have here also we need volume, which is CFM, and we need to go with friction. We take in terms of inches of water gas per 100 feet. Inches of water gas per 100 feet. Okay. Principles of duct sizing. Always the width of the duct should be greater or equal to the height of the duct. Always the width of the duct should be greater or equal to the height of the duct. Okay, next. Always the duct sizing should be in even numbers only. Aspect ratio equals to width divided by height. So the aspect ratio should be in between 1 and 9. The aspect ratio should be in between 1 and 9. So the aspect ratio which is equal to 1 or close to 1 is most preferred duct. The height of the branch duct should be 2 inch less to the height of the okay. These are the 5 principles. We work duct sizing according to these principles. Okay, so make a note of this. Make a note. This one completed. Is this completed?
Yes, yes.
No.
Yeah, make a note. Update me. I'll let you know. Sir, if you are unable to see the screen, just reload. You can get the screen again.
Yes,
Sir, both the system and my mobile, both is not working. So is
Only
it
your
possible any
browser.
other way?
Imtiaz, only you reload your browser.
Okay. Many time. Okay. Anyhow, once again I will check.
Is done. నాది ఆగిరు నీకు ఇంట్రెస్ట్
Hope it is done right.
Yes, sir.
Yes, sir.
Okay. So here A to B, B to C, and C to D. Assume this is machine. Here A to B, B to C, C to D is called as main duct. इसको हमें main duct बोलते हैं. B or also we call it as a trunk duct. Okay, we call it as a trunk duct also. BB1, CC1, DD1 and DD2. BB1, CC1, DD1 and DD2 are called as branch ducts. Okay, are called as branch ducts. Now B to B, B to C, C to D, BB1, CC1, DD1 and DD2. Assume this application is as a residential application. So as per SMACNA, sheet metal air conditioning contractors national association. Okay, sheet metal air conditioning contractors national association as per SMACNA. Okay, so for residential application for main duct, (700 to 900 FPM feet per minute lena, which is approximately 800 FPM we take. Branch duct, we go with 600 FPM. Branch duct 600 FPM has to be taken. So A to B, how much CFM we need to take, sir? Not able to see the screen. Yeah, from A to B, how much CFM we need to take?
Eight.
400.
No. 24.
Sum of all. Okay, so 2000 CFM should be there. Okay, 2000 CFM. That means 8 plus 6, 14, 14 plus 4, 18, 18 plus 2, 20, 200 CFM, which is 2000 CFM. There is some issue from your end. Internet issue is from your end. Okay, so remaining everyone is facing not facing any issue. There is some issue from your end. Please check with the internet connection, sir.
Okay, okay.
Okay, so B to C, it is 2000 minus 400, which is 1600 CFM. 1600 CFM. C to D, 1600 minus 800, which is 800 CFM. Now Ibrahim, Imtiaz, now you check, you'll get. Okay, so this tool is called as a duct sizer tool. I'll share tool with you. This tool is called as a duct sizer tool, and we are working now. The process is velocity reduction method. velocity reduction method. So velocity reduction method, we have flow rate and velocity. You need to select both, and you need to select the comfort temperature, which is 75 degree Fahrenheit, 50% RH. So A to B flow rate is 2000 CFM you take. Okay, 2000 CFM. And velocity you take it as 800 FPM. Why? Because it's a main duct. So it is showing equivalent diameter. It is showing equivalent diameter. So equivalent diameter is 21.4 inch, which is, I need, as I told, you need to take even numbers. So we make it as 22 inch diameter, 22 inch. Dia 22 inch. Next. So you type with 2. You start with 2 here. Rectangle. This is rectangular duct size. This is rectangular duct size or square duct, we say. You type with 2. It is showing 157. It is showing 157. So you make it as 158. One is even, one is odd. Odd number ko even pe convert karo. So 157 means 158. So 158 by 2. Next, I'll go with 4 here. I'll go with 4. Again 158 we got. (158 by 4). Again, I'll go with 6. It is 92. So 92 by 6. (8). 60 by 8. (10). 43. Again I told, even if it is odd, you make it as even. 44 by 10. (12). 34 by 12. (18). 20. 20 by 22 by 18. (20 by 19). That means 20 by 20. Okay. Now, as we discussed the first point, the first point is always the width should be greater and height should be lesser. So we have made bigger values in the width side. This is width and this is height. This is width, this is height. Now, what is the aspect ratio?
1:9.
Aspect ratio equals to
Width by height.
Width by height. Now tell me 158 by 2. How much will you get?
79.
78. 158 by 4. 158 by 4.
For almost 39.
39.
39.5.
92 by 6.
15.
How much?
15. See, 15, 6 are 90.
15. 60 by 8.
8, 8, 64, 8 almost.
So 7.8 some around.
Yeah, yeah.
4.
4.4.
4.4. 32 by 12.
Almost
Around
2.9 something.
2.8 in around.
Yeah.
1.2 in around and 1.
Yeah.
So the first statement, we made the first statement and we clear the second statement. Always the Duct sizing should be even numbers only. All the numbers are in even numbers. And the third statement, the aspect ratio should be in between 1 and 9 only. The aspect ratio should be in between 1 and 9 only, so that this is wrong duct size. This duct size we won't consider, and this duct size also we won't consider. Why? Because it is more than 9. Now, the aspect ratio which is close to 1 or equal to 1 is most preferred duct. This is equal to 1. Okay, which is most preferred duct. Therefore, the duct size will be a 20 by 20 inches, 20 inch by 20 inch, so that it will get the square duct. Next, B2B1. B2B1 400 branch duct. This is branch duct. So I'll directly come for branch duct. 400 is the CFM and 600 is the FPM. Change the 600. So that round duct 11.1 you will get. So that you go with dia 12 inch here. Dia 12 inch. Next I'll find the rectangular duct. So I'll start with 297. So I'll go with 4, 33, 6, 19, 8, 13. I'll go with 10. You are getting 10 equal. So the aspect ratio is 1 exactly, right? So that I'll go with 10 by 10. Next, B2C. B2C it is main duct again 1600. So 1600 and this is 800. 9.1 equivalent duct diameter is 9.1, 19.1, which is dia 20. So I'll go with the 12, 26, 14, 22, 18, 17. 18, 17 means what we need to take? 18 by 18 we need to take. Are you getting me? Are you getting me?
Yes, yes, yes.
Yes, yes.
Yes.
Okay. Next, C2C1. C2C1 is branch duct again. 800 and this is 600. 800, 600. So 15.6, which is 16 inch. And this is 18 by 11. You can decrease to 16, 14, 15 or 16, 13 is, which is that is the last value. So 16 by 14 you need to take here. 16 cross 14. Next, 800, 800. This is also 800. So 13.5, 14 inch. Dia 14 inch. No worries, Imtiaz. At the end, you will get the recording. Okay. I'll provide you the recording of this class. Next, 14 by 12. 14 by 12 is the least one you will get. Next, D to D1. So D to D1 is 200 and this is 600. 7.8 dia 8 inch. And this is 8 by 6. Next, D to D2, which is 600, 600, 13.5 dia 14. And so this is also 14 by 12. So in this criteria, statement 5 applies. So the forward, this is preceding duct and this is forward duct. Always you need to check with the forward duct. The forward branch duct height should be 2 inch less than to the height of the main duct. But here both heights are same. So this statement you need to change to that. So as it is 14 by 11, make it as 16. 16 by 10 it will come. So this is wrong. You need to make it as 16 by 10. What is the reason behind this is, this is width and the height of the main duct. Now if branch duct also, if branch duct width height are same, so with respect to the height you can make some fittings here. Okay, but you can make some fittings here, but with respect to width there is no space to make fitting. और rabbit joint भी हो सकता है, nut bolt भी हो सकता है, नहीं तो welded भी हो सकता है, so that air gets leak. So that is the reason the statement telling that maintain 1 inch on the top and 1 inch on as a clearance space, so that the width obviously increases. Now you have all 4 directions. There is a clearance space to make the fittings. Okay, so this is the reason we have a clearance space. That is the reason we changed the space here. Okay, clear? If you want, you can make a note of this. Just make a note of this.
Can you please share the screen? On the other tab.
Hello.
Hello.
Okay.
Hello.
done? Is it done?
So
No.
screen is not visible.
Sorry, I'm sorry.
And Vinod, just one query. This magma main duct,
Yes, magma
is
means
this universal?
magma means
The
sheet
value
metal,
sheet.
air conditioning,
Yeah. Hello. Hello. So are we done for today?
No. He'll join.
Okay.
hello, am I audible?
Yeah. Yes, Vinod.
Sorry, it's wiped out, so you can get from the recording. So I'll go to the new point.
Vinod, I have shared the screenshot, which you have told before.
Yeah, okay.
In the group it is.
Yeah. So let me share you the screen. Yeah. So this is the drawing which I'll share with you. So consider this as a main duct. Consider this as a main duct, and a main duct velocity you take it as 1500 fpm. Branch duct, once you receive a material, I'll give the exact values, the page numbers. 1000 cfm, 1000 fpm. Okay. Next, but don't consider this 24 feet, 22.5 feet, 22.5 feet. These are for drafting purpose, that will come later. Now if you see here, 3 diffusers 425 cfm each, which is 425, 425, 425, which is 1275 cfm, which is 1275 cfm. Okay. Next, 425, 425, 1275 plus 450, 450, 450. So 450 plus 450, which will become 900. 900 plus 450, 1350. 1350 plus 1275, 2625. Got it? This is how you need to calculate total CFMs. Is it clear now?
Yes.
Okay. I'll share this drawing in the WhatsApp group. Just allow me 1 minute. And also I'll share the duct sizer tool. For Mac, I'm helpless. I have only the software for Windows, sir. So this is the drawing. I have given you the drawing. Bye bye. No, bye. Bye, Ra. I'll share duck sizer tool with you. Just I'm compressing it. Yeah. Document. Yeah, you just extract that file. You just extract the duck sizer and you can use directly. No need of any installation. Clear? So start working on the duck sizing. Complete this project with respect to velocity reduction method. So when can I expect these drawings, this project completion?
On the next class.
By next class?
Yeah.
So you share it tomorrow.
Okay.
So tomorrow if you can plan something. I will be not available tomorrow, sir. So
Okay.
And we'll take the class on Thursday directly. Okay?
Okay. Yeah.
So we'll work on equal friction method on Thursday. On Friday we'll start duck drafting. Okay? So this is our schedule.
Sir, dock sizing to hello.
Yeah.
Sir, dock sizing वो नहीं खुल रहा है सर. File decomposition is not support लिख रहा है.
सर आपका iOS में सपोर्ट नहीं करता है, वो विंडोज पे ही सपोर्ट होता है. आपको मैं एक एंड्रॉइड एप्लीकेशन भेजता हूँ. आपका फोन तो एंड्रॉइड है ना?
हाँ सर है.
हाँ, मैं एक
फोन सर फोन में ओपन नहीं हो.
फोन पे ओपन करने के लिए मैं एक एप्लीकेशन भेजता हूँ, वो डाउनलोड कर रहा हूँ.
ठीक
है. ओके.
You need to have